So here we need to find the largest value of n for which 5 to the power of n would divide this evenly, meaning is a factor. So I want to share with you how I thought about it. In the beginning, and this is a strategy that I always take, is to rewrite this, meaning, because I know it's a difference, so I always think of factoring powers of 5. In this case, I noticed that this could be written as 1, 2, 3, 4, 5, which is really 5 factorial. And then you have 6, 7, 8, 9, 10. And you'll see later that this is actually not that important for this problem, partly because the powers are small. And so we can factor out a 5 factorial. We're left with 6, 7, 8, 9, 10. And then 2 times 1, 2, 3, 4, 5. So we'll see. And then 5 factorial has a single 5 in it. And here, between these two terms, I can factor out a 5. And I'll actually do the steps here so you can visually see what's happening. I'm essentially leaving all the terms without the 5. So you'll see that this entire term has a 5 square. You don't have to necessarily do this in the exam because it does take time to be writing all this. But you need to be very clear. So you can see that, actually, you can see I need to get rid of that because that's the 5 I pulled and collected it. So I know 5 square is the factor. Now, the key thing here is this term that's left behind. Do I know if it's a multiple of 5 or not? And I would actually have to multiply it to see if that's the case. In fact, what I'm going to do is to try to factor out terms so that my multiplication work is easier. So obviously, there, you can see that 2 definitely works, which is right there, answer choice A. But I do need to examine that this number, which, if it's a factor of 5 or not. So I'm going to pull common terms. I see a 2 and a 2. This 2 I'm going to pull out of here, so that's going to leave me 4. This 3 I'm going to pull out, that's going to leave a 3 here. And then that 4 also pull out. So if I take out 2 times, actually it might be easier to say that's 8. 2 times 3 times 8. So then I have 6, 7, 8 goes out, left with a 3 here, 1 minus 1. And then this number is 21 times 6, 126 minus 1. So yeah, this is I guess a hard problem because 126 minus 1 is 125. And many of you may have recognized that's 5 cubed. So actually, you'll see that 5 to the 5 is the greatest factor, I guess power of 5 that would divide this. So n is actually 5. Now, what are the other ways to do this problem? You can see that once you make a decision that this is the route you want to go, it can get a little bit messy, and you really can't afford to then take a different approach in the exam because you really just get one good shot. That's generally what I try to do. Now, of course, there may be other elegant ways to do it, and I'm going to try some other way. 10 factorial minus 2 times 5 factorial square to see, I think that was probably not a bad idea because it reduces the numbers. Yeah, because I think if I pull out a 5 factorial, 6, 7, 8, 9, 10 minus, which is back to where I was, I could actually just compute it at this point. And let me just see, because 5 factorial is 120, so that's 240. And then 9 times 8 is 72, that's 42, 6 times 7, and then I have a 10. 4, 14, and then 8, 28. So this is a little bit more grunt work. 3024. So what I have is 5 factorial, 30240 minus 240. Actually, it's not too bad. Some might even argue that this is actually more easier to do than what I did here, because you have to make sure you are factoring the right terms. You're not leaving one piece behind, because if you leave one, you make any slight mistake, that's going to change the answer. So I can see people arguing that this is probably safer in this case. So now I have a 5 here, and then I have 4 10s, and each 10 is going to have a 5 in it. So I'm going to get 1 5 here and 4 5s here. So again, I'll get 5 to the power 5, and n is equal to 5. So I wanted to give you in this problem how I would do under exam conditions. It's always messier than, for me to come up with a very clean explanation after the fact. So in this case, the numbers were small enough that you could do the computation. But I'm thinking if the problem was something like 100 factorial minus 2 times 50 factorial square, then certainly you would have to be doing factoring to count the powers of 5. That would be a harder problem. I actually don't even know the answer. But I know that we can't be doing any of this in that case. So sometimes the way the question is structured will give you an idea of your approach. So I guess I showed you the two methods to do this. They might have seemed somewhat messy as I'm working through this, because I'm just doing it on the spot. So hope that's helpful. And to recap, the answer is 5, choice D.